Okay, so number 1, we have iron 2 or ferrous. So ferrous is in the list. Ferrous is here, so that's Fe2 plus. So you're going to write it as Fe2 plus. And then sulfate is not sulfur, so therefore this is a polyatomic anion second column. So you're going to look at sulfate all the way down. Sulfate, so sulfate is exactly big S, big O with 4 subscript and then 2 negative on top. So that's going to be S and then capital O as well, subscript 4 and then 2 minus. And then we crisscross, mentally this time, we crisscross 2 and a 2. And because it's a 2 and a 2, what do? We simplify it and become 1, correct? And so simply, if this one will become 1, it is simply, the chemical formula will just be Fe and SO4 closer together, canceling your 2 and a 2. And of course, for the name, the chemical name, no need to change anything for the names of the cation and anion. So simply copy them. I want to use the first name here first. So iron 2, I'll use iron 2 first. So that's iron 2. And the second name, anion, is sulfate. So that's iron 2 sulfate. Or I can use the second name, ferrous. So I can have ferrous. And of course, the anion will remain the same. That will be sulfate. So iron 2 sulfate or ferrous sulfate. That's your number 1. Now, let's go to item number 2. Item number 2 is ammonium and chlorate. So ammonium and chlorate, we go to the list of ions because these two are not elements. So these are big polyatomic ions. So ammonium is cation. I look at it in the first column, ammonium. So that's the first one in the list. So you see NH4 subscript 4 plus. So we write it down. That's your capital N, capital H, subscript 4, then plus on top. And then chlorate is also a polyatomic anion. We're going to look at C and look for chlorate. So chlorate is Cl, capital O, subscript 3, negative. So let's write that down. ClO3 negative. Now, inspect your oxidation numbers value. Our oxidation numbers are both 1 and a 1. So this is also very simple if both are 1. All I need to do is put this and this one closer to each other. So that's going to be NH4. Copy always the subscript that you have there and also the ClO3. So that is your final chemical formula for the ammonium and chlorate together. And of course, the name will just be ammonium. So stick to the names here, and the name here also for the anion, that will be ammonium chlorate. And that is your item number 2. Item number 3, we have copper 1 or cuprous. Now, automatically, if you see an item with a Roman numeral, I told you yesterday that that Roman numeral will make your life easier because it will tell you the value of the charge right away. So copper symbol is Cu, and there is a Roman numeral 1, so that means the charge is just a 1. And of course, we don't need to write a 1. All we need to do is write the plus to indicate that that is your metal cation. So Cu plus is copper 1. If ever copper 1 is not there, just cuprous, then it will be part of your list. Cuprous is here, and that's also Cu plus. So they're the same. I just made sure that I provide you the two names so that you get more familiar with it. Okay? And the second one is carbonate. Carbonate is not carbon because carbon is the element. So if it's carbonate, it means it's a polyatomic anion, second column. So I go to letter C, carbonate. So carbonate is CO subscript 3, then 2 negative on top. So I'm going to write that down. CO3, subscript 3, and then 2 negative up there. So let's crisscross this mentally. So the 2 from carbonate, just these 2 here, not including this, subscripts, never include them, just the oxidation number. So the 2 right there will go to copper. So copper will have a subscript of 2. While this one, it's just a 1, and it will go to CO3, so CO3 will remain CO3 because it's just the one that you're carrying over there. And then we're going to name it. So we're going to use either of this name here for the metal. The metal can be copper 1, so I'll use copper 1 first. So that's copper 1 carbonate. Or I'll use the second name, cuprous. So I can also name it as cuprous carbonate. And that is the final name for this pair right here. The fourth one is zinc and nitrate. And we know that zinc is found in the middle part of your periodic table. So that means you don't depend on the periodic table, but instead you go to your chart for zinc. So zinc is a cation because that's written first in there, and you look for zinc. Zinc is here, so that's Zn2+. So Zn2+. And then your nitrate, of course that's not nitrogen, so nitrate is found in your list of ions in the second column for the anion. So let's look for nitrate, that is NO subscript 3 negative on top. So that's going to be NO subscript 3 negative. Okay, so let's look at how the oxidation numbers here will be crisscrossed. The 1 will go to Zn. So the 1 from the nitrate will go to Zn. So that will just be Zn. And then the 2 will go to the whole NO3. It will go to the whole NO3. So what do we do in order to make sure that the NO3 will have entirely the 2? You have to make sure that you enclose it in a parenthesis and put NO3 first inside the parenthesis before you transfer the 2 from the zinc, so that the identity of your nitrate doesn't get removed or doesn't change. So NO3 is NO3, but with the 2 there, it indicates that the quantity of NO3 will have that 2 number, the number outside. Okay? So that parenthesis will only be applicable if you're putting a number. If you're putting a number for a certain polyatomic ion, that's more than 1. It makes no sense if it's a 1 and then you're going to enclose it in parentheses. But it makes sense if your number is more than 1, then there is a need for that parenthesis inside or to enclose your polyatomic ion before you place that number that you transferred. Okay? And so we name it as just plainly zinc nitrate. So that will be zinc nitrate. Okay? The second to the last one. So we have mercury 1 or mercurous. Oh, here we go again. We see a Roman numeral. So mercury is Hg, and that 1 will indicate it's just a plus. Phosphate is not phosphorus because phosphorus is the element. Phosphate now is a polyatomic anion. So let's look for phosphate in our list. So you see, don't get lost. There's phosphate and there's phosphite, I-T-E. So the one in the given is an 8, A-T-E. So phosphate, this is what we will use. So that's PO4, subscript 4, and 3 negative is the charge. So PO4 and then 3 negative. So that will be PO4, 3 negative. When you crisscross, you look at the second oxidation number first because that second oxidation number goes to the first element. So the 3 goes to Hg. So when you write down Hg, Hg will become a 3 here. We'll have a subscript of 3. And Hg is just a 1. So PO4 will just be PO4 only. So just write it as PO4. And now we're going to name it using either of this name here. So we can use mercury 1, Roman numeral 1, and then phosphate. If you want to use the old name, so you can put or there. So that will become mercurous phosphate. There you go. And then finally, we have sodium and cyanide. Oh, sodium is an element. You're familiar with sodium. Sodium is an element that we know, and sodium has a symbol of Na. So let's look for Na in our periodic table. Na, you know that if you're familiar now with your periodic table, which you should be by now, Na is here in group 1. So that's just a plus. So sodium is Na plus. And then we have cyanide. Oh, cyanide is never an element, so you have to look at it in the second column of your list of ions. So cyanide, letter C, we go down. Oh, there you go. Cyanide contains carbon and nitrogen and no numbers. So 1 carbon, 1 nitrogen with a charge of negative only. So Cn negative. That's my cyanide. So let's go ahead and write that down here. So cyanide is Cn, all capital letters, negative. And this is so simple because both are 1 and a 1. So basically you're just putting Na, C and N closer to each other. And that is your sodium cyanide. Names stay the same. And so that concludes this particular work for our second part dealing with ternary ionic compounds.